This video is on how to draw ionic bonds. So we're going to look at ionic bonding. Remember, ionic bonding always occurs between a metal and a non-metal. So one of the first things with any bonding question you must do is identify what type of bonding it is you're being expected to draw. So the most simple and sort of classic example that you are often given is like something like NaCl. And so it's up to you to kind of identify by looking at this that we have a metal and a non-metal, and therefore we're going to draw ionic bonding. Just a general reminder, how do you know whether something is a metal and a non-metal? When you look at the periodic table, all of the metals are on the left-hand side of the periodic table, the non-metals on the right. If you draw like a line here above aluminium, coming down like a staircase going across, the elements to the right of this are non-metals. So we're looking at like the halogens, group 7, for example, oxygen, sulfur, nitrogen, carbon, these are all non-metals, and everything to the left of that is a metal. So you can see the majority of the periodic table is a metal. When a metal reacts with a non-metal, they bond ionically. And that is because in ionic bonding, as we will see, the metal always loses electrons, it gives up its electrons, and it gives those electrons to the non-metal in order to complete the shell. So ionic bonding is defined as the electrostatic attraction between a positively charged and negatively charged ion, and that occurs when a metal and a non-metal react. Okay, so how do we do it? Well, when we look for any metal, if I was to draw the electron configuration for sodium, so on the periodic table, sodium is got an atomic number of 11, so that means it has 11 electrons. Its electron configuration is therefore 2, 8, 1. If you were to draw that in full, you would have Na and the 2 electrons, then your 8 electrons, and then your 1 electron in the outer shell. When sodium forms an ion, what it wants to do is it wants to have a full outer shell, and it is easier for sodium as a metal to lose this 1 electron to go down to this full outer shell than gain 7 more. And so when it reacts, what we would draw is we would just write sodium, and we show the 8 electrons in its outer shell. Now understand, I've not bothered to draw the inside electrons here because that's unnecessary. So in your exam, you only ever need to draw the outer shell, and you can draw it like this, and then all you need to do is put it into square brackets, and the number of electrons in the outer shell for any metal, you're just going to plus that number, because that's when it loses 1 electron, it will form an overall +1 charge. That is also the same as the group on the periodic table. So anything in group 1 will form a +1 charge, anything in +2 will form group 2, anything in group 3 will form +3. So for any metal, when you are drawing the ionic bonding, all you have to draw is an outer shell with 8 electrons, and it's the same for every single metal. There is only one exception that you can be given where it isn't, and that is lithium, and that's because lithium only has 3 electrons to begin with. So when you lose your 1 electron from your outer shell in the case of lithium, you're only left with the 2 electrons of the first shell. And that's the only exception to the rule. All of the metals that you will be asked to draw at GCSE level can be drawn like so. Okay, so now how do we look at doing non-metals? So if metals can be simplified, and it doesn't matter what the metal is, we can just simply put 1 circle, 8 electrons, square brackets, and then the only thing we need to remember is that this number is the group, okay? So you always put a plus, metals are always a plus, but it's just the number is whatever group it happens to be in, so group 1, group 2, or group 3, okay? So all metals can be like that. The only exception is lithium, where there's only 2 electrons to have. Then non-metals are a little bit trickier, so this is the one that you need to think about. So for example, if I'm doing chlorine, what I need to do, same basic starting point, is I think about chlorine's position on the periodic table, think about the numbers. It's got 17 electrons. So its electron configuration for chlorine is 2, 8, 7, okay? And so what you need to think about is simply, if I was drawing electron configuration for this, I only have to, again, draw the number of electrons in the outer shell. So I just need to draw 7. Like, what do I need to make this up to 8? Okay, so if I'm drawing chlorine, what I would do is draw a chlorine, draw my circle, and I draw my 7 dots. So I do it as dots just to show in contrast to the electrons in the metal that we just did. Okay, It doesn't actually matter which way around you do it as long as they're different. Okay, so I draw 7 dots. Okay, so 7 dots, the number of electrons in the outer shell, that's how many dots I do. And then all I have to do is just make it up to 8. So clearly, to make it up to 8, I just need to add 1 cross. Okay, so I add 1 cross to make it up to 8. Okay, so that is now adds up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Put it in square brackets. And I always put a minus, and the number that I put here is the number of crosses. So minus 1. Okay, so that is the process for a non-metal. So a non-metal, you look at the electron configuration or what group it's in, and you draw just the outer shell, just the group number of electrons. So in the case of chlorine, it's 7. And then you make it up to 8 with a cross, okay, however many you need, and then put that number here. So let me just do another example, okay, for both of these. So if we were to do barium iodide, okay, and I'm doing barium iodide because this is a group 2 and a group 7 element again, okay, just for reference, but they're ones that you're slightly bigger and slightly less familiar with. So what you can't do with these is you can't like write out the electron configuration, but what I can do is I can say, okay, well, barium is in group 2, okay, so because it's in group 2, it's going to have an outer shell that's obviously going to have 2 electrons in it, so it's going to form barium plus 2 ions. Okay, but none of that actually matters because all I need to remember is for a metal, I draw a circle, 8 crosses, and then whatever the group is, which in the case of barium is group 2, I put that number plus. Okay, so barium's obviously got a lot of other electrons in it, but if I was using this technique to do it, that's what I would do. Okay, the only exception is lithium. For iodine, again, I look at what group it's in. Iodine is in group 7. Okay, so the fact that it's in group 7 means I'm going to draw my 7 dots. What do I need to add it up to 8? I need to put 1 cross in there, and then I put minus the number of crosses, which is 1. Okay, now one extra thing to think about this is in the formula of this, it's I2, so I could draw iodine twice here. Okay, another way of doing it is I could just put 2 in the bottom right hand corner, or put times 2 in front. Either of those are acceptable, just to show that there's 2 of those. Okay, one more example. So this time if we were doing aluminium oxide. Okay, so aluminium is obviously a metal, so I don't think about it. I just simply just put a circle, 8 crosses, square brackets, plus, and then whatever the group it is, which in the case of aluminium is group 3. Okay, so nice and simple. And oxygen is, when you check on the periodic table, its electron configuration is 2, 6. It's in group 6. So when you do oxygen, you do now this time 6 dots. And it's the same question. How many do I need to draw to add up to 8? Okay, so I then draw 2 crosses. Okay, put it in square brackets. Don't ever forget the square brackets. It's important, really simple mistake to make. And it's always minus the number of crosses, which in this case is 2. Okay, so that's the pattern of how you work out ionic bonds. Metals, remember, are really simple. You can always draw them the same way. One thing I'll just mention about metals is you can actually draw them even easier than this, because it's a full outer shell, instead of drawing the full shell here, you could actually draw the empty shell that's left over. So it would also be acceptable to just simply draw that, or to draw that for a metal. Okay, and actually not even show the crosses, because you're showing the empty shell where those 3 electrons, aluminium's electron configuration is 2, 8, 3, and it's these 3 electrons that are lost when it forms a +3 ion, so you could show that empty shell like that. So actually either of those are accepted at GCSE level on the mark scheme, so you can do either. But my advice would be just always do the same approach every single time for metals, and just stick to doing that. for simplicity. It also makes it clearer then where your crosses from here have come from. So it's this idea that you would have 2 aluminiums and 3 oxygens in Al2O3, and the 2 aluminiums would each lose 3 electrons each, which gives you 6 in total, and those 6 electrons, 2 would go to each of the 3 oxygens.